Here's your starter for today. If you pause the video, have a go at the questions, and then I'll reveal the answers. Okay, answers are coming now. Hopefully you remembered how to find acceleration from velocity, differentiate, or find a gradient. And distance is area under the curve, or integrate. Here's the method for question 2. Today we're going to look at numerical integration using the second of the two methods you're expected to know for A-level. So this method is the trapezium rule. This is what we've already done. We've looked at using rectangles to either under or overestimate an integral. We can see that they're not very close. So a better way of doing it would be to use a trapezium. So this trapezium is much closer to the original curve than using a rectangle would be. With a bit more detail here, we can see that a trapezium doesn't just touch the curve in one corner but in two corners. So we're going to be using the y coordinates quite a lot, and they're often referred to as ordinates. So as a pair we have coordinates, as individuals we have x ordinates and y ordinates. Each strip or trapezia is called an interval. We can get better estimates if we use more narrower trapezia, just like with the rectangles. So here we go, we have got a single interval here, or the question might say one strip or one trapezium, or it could say two ordinates because the trapezium touches the curve in two places. Better than that would be to have two. We can see already that the gap is closing. We have either two intervals or we have 1, 2, 3 trapezia, ordinates, sorry, 2 trapezia, 3 ordinates. When we have 3 intervals or 3 trapezia, we have got 4 ordinates, 4 places where the curve touches the strips. And we can carry on. A much better one here we can see is when we've got 10 intervals. So it's really close and I can't see with my eyes any difference between the area of the trapezia and the area between the curve and the x-axis. We're going to explore whether we get an underestimate or overestimate next time. With rectangles we could tell straight away. With trapezia we need to be a bit more careful. So we need to find an expression now that's going to give us an estimate for our integral. Here's our example. When we're using y is e to the negative x squared and we're integrating from 0 to 1. We're going to use a single trapezium here. So remember the singular is trapezium and the plural is trapezia. We find the area of a trapezium, if you remember from GCSE, by doing half the sum of the parallel sides multiplied by the perpendicular height. So the parallel sides here are the y values, okay, so they have the same length as the y values of where the curve meets the trapezium. And the perpendicular height is between the two parallel sides, and that is the width of the strip. So for this example, the width is 1. We want to do half of 1 multiplied by the sum of the parallel sides. So we've got e to the 0 for this one and e to the minus 1 squared for that one. In general, if instead we have a function f of x, or y's f of x is our curve, going from a to b, then to get our perpendicular height, we would do b minus a and divide it by 1. We only have one strip, so b minus a. We want to find half of that perpendicular height, and then we want to multiply by the sum of the parallel sides, which is the sum of y0 plus y1, gives us our two heights. See what happens when we have two intervals of equal width. So this time we take our width here, which is 1, and we divide it by 2 to get a single strip width. Okay, so each trapezia has got width 0.5. We want to do that width divided by 2. And then we need to multiply by the sum of the parallel sides. So for our first trapezia, that is y0, so e to the naught, plus e to the minus a half squared. And then for our second trapezium, it's exactly the same width, so we have the same width divided by 2, and our parallel sides are e to the minus a half squared again, and then e to the minus 1 squared. We can see that we have a common factor of the width divided by 2, so we take that out, and then let's look what goes in the brackets. We have a single e to the minus 0 squared, we have a single e to the minus 1 squared, but we have used the middle height twice, so we've got two lots of e to the minus a half squared. In general, that works exactly the same way. So to get our width of each individual strip, we would do the full width, b minus a, divided by the number of strips, 2, and then we need to times that by a half. So we've got b minus a divided by 2, and then half that, so b minus a divided by 4. The parallel sides for the first strip are y0 and y1, and for the second one are y1 and y2. So we can see that the middle one occurs twice. So if we take our common factor of our width divided by 2 out, there we go, then we have got a single y0, a single y2, but two of the middle ones, 2y1. Let's see, when we have 3 intervals, the same sort of thing happens. Okay, so this time to get our width, we're going to do 1 take away 0, which is just 1, divided by 3, so we've got a third, and then we want to halve that. So we've got a third halved. Okay, then for our first trapezia, the parallel sides are e to the 0 squared and e to the minus 1/3 squared. So we put in the x values into e to the minus x squared to find out the y ordinates. So I'm putting x is 0 and x is a third into my formula here. For the next trapezia, I have exactly the same width, but this time the x coordinates I'm going to put into my y values are 1/3 and then 2/3. So we'd substitute those in to get our y ordinates. And then finally for the last trapezia, we've got the same width, and we want to be using 2/3 for our x value and 1 for our x value. We substitute them into e to the minus x squared. So again, we have got a common factor of a third over 2 we can take out, and let's see what goes inside. We have a single e to the 0 squared, and we have a single e to the 1 squared, but for both of the others, for e to the minus a third squared and e to the minus 2/3 squared, we have got 2 of those, so we can group those together. Okay, a similar thing happens, or exactly the same thing happens, when we're looking at the more general one. So we do, to get a single strip width, we do the full width divided by, in this case, 3, b minus a over 3. But then we need to halve that, so that's the same as b minus a over 6. For the first trapezia, we've got y0 plus y1. For the second, y1 plus y2, so we've reused that y1. And the next one, y2 plus y3, so we've reused the y2 again, which means that we have a single y0, a single y2, but double of the ones in the middle. Right, let's generalize so that we've got n intervals this time. So we have n different trapezia. To get our width, we're going to do our full width, which is 1, divided by the number of strips. So I'm pretending there's n here. So we're going to have 1 over n. But then we have to halve that. So we always do the width, which is the parallel height, halved. Okay, and then our heights are going to be the y coordinates for each strip. So the first one is we're substituting in 0, so e to the minus 0 squared, and e to the minus 1 over n is going to be our first x coordinate. So because they're only 1 over n wide, these strip widths, the first x coordinate is 1 over n, the next one's 2 over n, 3 over n, and so on until we get to n over n. So there's our first area of trapezia. For the next one we have the same width, but we're using the x coordinate is 1 over n and then 2 over n. and then we'd have 2 over n and 3 over n, and we'd continue until we get to the last one, which is still the same width. And then our last one, we'd have n over n and n minus 1 over n for our x values that we substitute in for our y values. Yet again, we can see that we're reusing in the middle heights twice every time, but we only use the end ones once. So we can take out the common factor. We have our end y values once, so e to the minus 0 squared and e to the minus 1 squared, but all of the others we use twice. So we've got 2 lots of all of the middle bits. Okay, let's see that when we're doing it in the more general case with y as f of x, and our limits are b and a. So to get a single width of a strip, we do b minus a and divide by n, but we need to halve that. So we've got b minus a over n, and then half it is over 2. We will only use our end values once again. So these are the individual areas of the trapezia, and you can see that we go y0, y1, then y1 again, y2, then we'll have y2, y3, and so on, all the way up to yn minus 1, yn. We only use the y0 and the yn once. So the end ones are used once, but all of the middle ones are used twice. So this gives us our trapezium rule, except this is a bit of a faff at the beginning, so we just simplify how it looks. And this is the formula that you get on your on your formula sheet. So if we're trying to integrate some function y of x with respect to x, going from a to b, then we're going to work out how wide each strip is. So h is just how wide the strip is. So we do the full width and divide by how many strips we've got. We need to halve that, and then we need to add up the end heights, one of each, and we need to double the sum of the middle heights. So a way of remembering it is h over 2 times the first plus the last plus twice the sum of the rest. Okay. We call the number of intervals is n, and h is the width of each interval. The y values are called ordinates, and there's always one more of them than the number of intervals. If we want to improve accuracy, we just use more intervals. Let's try an example. So there's our trapezium rule at the top, and that's what we're going to be using. We're going to use the trapezium rule with 5 intervals, so n is 5, of equal width to find an approximate value of the integral of from 0 to 1 of e to the minus x squared. So the one we've been looking at, but let's get an actual value this time. Because it says find, you don't need to put every item of detail down, but it's really important to stay organized when you're working on the trapezium rule, because otherwise it's very easy to lose track. Okay, so let's write down our key bits of information just to make sure we know what's going on. So we're going from a is 0 to b is 1, and our widths are going to be b minus a over n, which is 5. So that gives us 0.2. So I've worked out the values of the different letters that we need to use in our formula. Okay, what I haven't worked out yet is I haven't worked out the y values. So let's see about, first of all, we'll need some x values and substitute those in to get y's. Well, it's pretty obvious for these that we're going up in 0.2s up to 1, so there's our x values. You could use your calculator to find that. We just want to find our x values. Okay, going from 0 to 1 in steps of 0.2. Okay, we aren't doing any fancy formulas, it's just find the basic numbers. So find x, where our variable is called x, going from 0 to 1 in steps of 0.2. So that's using the same process as you used when you're doing rectangles, but we don't have a fancy formula here. Now I've done arrow list 1 because I want to store that in my calculator, because then I can just pop it in to get my y values in a second. Here, first of all, to see where we're heading, is our formula, it's always a good idea to quote the formula. And here are my values going in. So I've just substituted my x's into my formula, which is e to the minus x squared. I've literally copied it from above. We have got h over 2, the sum of the two end ones, so this is e to the minus 0 squared, e to the minus 1 squared, plus 2 times all of the rest, all of the in-between x values. If it's a bit of a palaver to write down e to the minus something, you could instead work out your y values first and just jot those down instead. Okay, you'll have to do that if the question requires more detail. You have to show your y values. You can get your y values on your calculator. Okay, if you worked out your sequence already for your x values and stored them in list 1, you can simply calculate with that. So e to the minus list 1 squared gives us list 2. Alternatively, you can use the method we used for rectangles and set up a sequence. So we're still in the option of list, sequence, and the sequence we want is e to the minus x squared, where x is the variable going from 0 to 1 in steps of 0.2. And I have stored that in list 2. Okay. So to calculate our answer, we can just type it in. So if we look back at what we've got, here's our method. You can type that in as you see it, but if, like me, you're likely to make silly mistakes when you're typing, okay, there's a slightly more efficient way of doing this. And I will show you on the calculator. Right, we want to be in run mode, okay, and then we're going to be using options, and I'm going to just get my list set up, so options and list. So I'm going to put my x values into a sequence. So we've got a sequence. I want to just have a load of values. I'm going to call my variable x. I'm going from 0 to 1 in steps of 0.2. Okay, and instead of just executing, I'm going to store that in a list. So I press list 1. There we go. There's my numbers. And then I want to get my y values stored in list 2. So I'm going to calculate with that list. I'm going to do e to the minus, and then I'll just put it in brackets just in case, list 1 squared. And then I want to put that in, so arrow list 2. Okay, that's just a little fuzzy. I'll try and make it sharper for you. Okay, right, so now we have our list. So we need to do h, which is 0.2, divided by 2, times by the sum of the end ones. So that is list 2, and I want the first item in list 2. So to get that, you do square brackets, which is shift plus. And I want the first item in list 2, and then shift minus closes those brackets, plus I want the last one, so I'm going to do list 2, and the last one is there were 5 strips, so there were 6 ordinates, so it's going to be the 6th thing in the list, and shift minus to get the end of the square brackets. And then I want to add up all of the other ones, so I want to do 2 times the sum of the middle ones. So to get a sum, you can go in math, or I'm just going to exit once, and I can see that I've got one of my options is calc. So there's my calc, and in here I've got summation. I pressed F6 till I can see the sigma symbol. So that's the sum of. So I want to have the middle ones, don't I? So I'm going to do options list again, list 2, and then my square brackets, so shift plus x, shift minus to end my brackets, and I would like to do the x is going to go from the second item on my list up to the 5th item on my list. So I've got h over 2, 0.2 over 2, times by the first item on my list and the last item in my list, plus 2 times the sum of all the other items in my list. Execute, and And there we go, that's our value. If I want to check it's sensible, then again I can exit and calculate and use the integral. So I want to integrate e to the negative x squared from 0 up to 1, 0.747. So we're pretty close with our estimate of 0.744. Let's have a look where we got up to. So I've written down here what you do on your calculator. Alright, here's our method. So we jotted down the key bits of information that we're going to substitute into our quoted formula. So quoted, substituted, done it all on my calculator, and we've got 0.744. We've checked that we're pretty close, and we are, so that seems sensible. Right, let's try a second example. This time we want to integrate cos of x from 0 to pi over 2. And this time the question says we're using 5 ordinates, which means 4 strips, 4 trapezia. The question also used the words determine, so we've got to make sure that we write down our y ordinates, because you get marks for those. Okay, so here we go. I'm going to jot down first of all my key bits of information so that I don't miss them. Okay, so I know that if there's 5 ordinates, then there's going to be 4 intervals. I'm going from 0 up to pi over 2, and so my width is going to be b minus a over 4. So that's pi over 2 minus 0 over 4, and that simplifies to give me pi over 8. Right, I can now get my x values by typing onto my calculator, okay, the sequence going from 0 up to pi over 2 in steps of pi over 8. So I've worked out my h first to make it easier then to type into my calculator. Okay, and I want to then find out cos of that and pop it in list 2. And that should give us these values here. Okay, so I'll just show you how that happens on your calculator. Okay, so let's get our x's first of all. So I need to be in the list option. Okay, and we're doing a sequence. So we just want our x's first of all. So x is a variable, and it's going from 0 to pi over 2 in steps of pi over 4. Sorry, pi over 8, wasn't it? Okay, and I'm going to store that in list 1. Okay, there's my x's. To get my y's, I'm going to just double check, am I in radians? Yes, I'm in radians, that's good. Okay, so I want to do cos of list 1. I'll pop that into list 2. Okay, so that's me getting my x's and my y's. Okay, so we now quote the formula. We've got all the information. We've got our n is 4, we've got h is pi over 8, and we've got our y values. So we write that down, putting the right numbers into place. Oh, just see where that's gone. Okay, let's just see. So there's my h, and there's my y0 and y5, and then here's y2, y3, and y4 that go in the middle. Okay, so we want to find out what that is, so let's do that on the calculator. Okay, so we've got 8, which is pi over 8, and then we need to divide that by 2, so okay. We need to multiply by the sum of the first and the last terms, so remember for that we're going to do list 2, and we do shift square bracket, shift plus for square bracket. So we want the very first one, and we want the last one, which is the fifth one. So list 2, square bracket, the fifth ordinate. Okay, plus 2 times the sum of the bits in the middle. So I'm going to exit, calc, F6 to get sum, okay, and fill this in. So then I'm going to do options list. Again, so list 2 and square brackets X, because this is the thing that changes, is which item of the list we're having. And we want to have X going from the second item in the list up to this time the fourth item in the list. Okay, and that gives us 0.987. Let's, while we're here, check out what we ought to get when we integrate. So I'll exit and calc and integrate cos of x from x is 0 up to 1, and we get 0.841. So that's not bad. Okay, so again I've just written down how you could calculate that, and we'll just write down, okay, what we got, 0.987. So just to show you the method again, we write down what n is and what h is. H usually gets you a mark. We work out our x values and write down in particular the y values. The crucial bits to write down are h, and then quote and substitute into your formula, writing down the y values. So it may be less confusing to write the y values down in the correct order first, so you can pick out the first and the last, and then the middle ones to put in the right places. Okay, we've done that on our calculator, and finally we write our answer to 3 significant figures. Okay, one last example. We're going to, this time, use the trapezium rule with 5 strips, so n is 5 this time. And we're going to estimate the area of the integral 1 over 1 plus x squared from 0 to 1. So let's write down what we know first of all. We know that n is 5 strips. A, we start at 0, b, we end at 1, and to get h, we do b minus a over n. Remember, to get that, you're given the formula for h. So you just pop your numbers in. So 1 taken with 0 over 5 gives us 0.2 again. Okay, to get our x values, we can go onto our calculator, and then we can calculate the y values as well. Okay, so once you've got those, it's usually a very good idea to write down what the x and y values are, so that you don't get mixed up when you're filling in your substitutions. There is the formula, and now we fill in everything we know. We know that h we've calculated as 0.2. We know that y0 and y1 are 1.5. And we know that all the middle ones are the ones we've listed just above, which I got on my calculator. And then finally, you can either type that in as it is. Because these are nice exact fractions, you could type that in without worrying about rounding error. If you've got decimals, you can type it as you see it, but you need to have enough decimal places so you don't end up with rounding error. Okay, or you can use the method we just used, where we're using the sum of. We're using list, square brackets, and the sum of. Or you can type it as you see it. It's your choice. Okay, right then, so if you do that on the calculator, maybe you should have a go. So if you pause, have a little go, and see if you can manage to work the calculator to get the correct answer. Going back, if you wanted to see what how to get your x and y, there we go. And now going forward to see the method for calculating the actual value of the integral. And this is what you should have got, hopefully. 0.784. On my calculator, when I then checked my answer, okay, I've ended up with pi over 4, which is 0.785 to 3 significant figures. So that's pretty good, isn't it? Okay, so finally, here are some questions for you to try. There's a couple of pages, so here's the first page. Pause here. Okay, and I'm going to reveal the answers now. Right, another set of questions. So just questions 5, 7 and 8 from exercise 15b in your book. And now I'm going to reveal the answers. Okay, tomorrow we're going to look at some slightly trickier questions and consider over and underestimates.